Hello M3, this is Teacher Win and welcome to another lesson about light. For this video, we are going to talk about convex mirror, your concave lens, and your convex lens. In our last lesson, we talked about your concave mirror, by which we knew already how do we make this concave mirror. Also, so we identify the focal point, which is the center of your circle, and also your 2F, which is the side of your circle. Also, we identified your principal axis. So this is the line that divides your concave mirror. Also, your concave mirror has two sides. So you have here your reflective surface or your shiny side, and as well as your hard surface. So let's continue with our lesson. So we are going now to your convex mirror. Your convex mirror is made from a circular mirror by which that mirror is cut into half. So your convex mirror after cutting will look like a letter C. So just like your concave mirror, so your convex mirror has two parts. So you have your shiny part and your hard part. So your shiny part, that is where the light is reflected back. Also, your convex mirror has your principal axis, by which this is your focal point and this is your secondary focal point. So this is your F1. Again, this is your F1. And then this is also your F2, or some books they wrote there 2F. So this is what your convex mirror look like. So that's the summary. So you have there your focal point or your 2F and also your F2. So you have your shiny part and then your hard surface. So how do we use this convex mirror? So our situation here is that we place an object that is far away from your convex mirror. So so using your ray diagram, so we are going to trace how does your image is formed. And looking at this criteria here, so you are going to think, what do you think is the image size? Is it big or small? How about the orientation? Is it standing or upright or inverted? Or is the image real or virtual? So you can pause the video to make your own ray diagram. And after this one, try to guess if it is the image size, orientation, and is it real or virtual. Okay, so let's try to check your answers. So first, in your ray diagram, so you are going to make an arrow or a line starting from the top of your object and then going to your mirror. And then since this is the shiny surface, so it is expected that the light will reflect or it will bounce back in an angular direction. Okay, so if you look at here the side, so it's an angle here, so the light will be reflected away to the mirror. Also, when you are using your ray diagram so don't forget to make an arrow because this will show where does your light come from. So from this diagram, so as if, or shall we say, it is reflected this way, as if the light is coming from the focal point. Remember that this is your F1, right? Next, you're going to make the second arrow or the second line coming from the top of the surface, and you're going to make an arrow that is pointing to your focal point. But remember, this is a mirror, so the light will be reflected away, just like this one. Okay, so from this diagram, so as what I've said, so you're going to make an arrow that is pointing to your F1. Okay, so now where is your image? Remember that an image can be formed when two lines meet each other, right? So where's that line wherein the image can be seen? So obviously it's not the focal point, but it's actually on this side. So after you reflected this arrow, or this line, I mean, so you have to make, okay, so you're going to make a line as if the line is come or the light is coming from this part. So as you can see here, so this is the area wherein the two lines meet each other. So that means an image can be formed in this part. So our question here, so what is the image size? So the image size is small. What is the image orientation? Since it is standing, so it is upright. And therefore, so the image is virtual. Our next situation is we move now the object closer to the convex mirror. So using your ray diagram, so identify if the image is what? Big or small? Image orientation, is it upright or inverted? And the image is what? Real or virtual? So you can pause the video and make the ray diagram and try to check if what is your image. Okay, let's check your answer. So again, first, we're going to make a line, a parallel line on the top of your surface or the top of your object, pointing to the arrow, pointing to the mirror. And then, since this is a mirror, it's expected that the light will be reflected. So the second thing is, you're going to make a light ray that is pointing away from your mirror. So again, don't forget to write an arrow. And then this reflected ray, so you're going to make an imaginary line as if the light is coming from your focal point, just like this one. Next, you're going to make your secondary ray diagram. So from the top of the surface, from the top of the object, going to the mirror, and it will be reflected back. So don't forget to make, again, the arrow. And then, this incident ray, so you are going to make an imaginary line pointing to your focal point as if the light is coming there. And then with your reflected ray, so you're going to make a line as if the light is coming from this side. So the point wherein the two lines meet each other, that is where your image is formed. So therefore, the image size here is still small. And then the image orientation is still upright. And the image here is still virtual. So therefore, even if you place an object away or near your convex mirror, all images are smaller, all images are upright, and all images are virtual. So just look at this picture, right? So this mirror can be found along the street. So as you can see here, so the image of the van is small, right? Also, the van's image is upright. And since it is upright, so the image here is virtual. The next part is, let's talk now about refraction. Please take note, this is refraction of light. When you were in elementary or maybe P4 or P5, you always, or I think you did this one already, wherein you place a pencil into a glass with water. And if you look at the side, so as if the pencil is broken, but actually that is because your light bends. So refraction means the bending of light. So this is the actual pencil. So if you place it into the water, so the pencil is supposed to be straight, right? However, since the light bends as it enters the water, so as we see it, as if the pencil is broken, but actually the pencil is not broken. It's just that the light bends. Okay, the light from the pencil is bent. Okay, So we are going to talk more about refraction in some of our examples, but please take note that refraction can happen in solid, liquid, and gas state. So for our next example, so we are going to use your lens, which is an example of solid, to show how does your light bend. So about your lenses, so there are two types of lenses. We have your converging lens and your diverging lens. So we have here your examples, your biconvex and your biconcave. Please remember, or please take note that the word bi, it means double, right? So the word bi means double. So if you say biconvex, so that means it's a double convex. If you say biconcave, then that is a double concave. So lenses can be shaped into different shapes, and it is made of glass or sometimes plastic. So with your converging lenses, so we can have your double convex, your plano convex, your converging meniscus, and then for diverging lenses, so we have your double concave, plano concave, and your diverging meniscus. But we are going to discuss this one by one. So in your convex lens, so it is thicker at the center than the side. So that means if we are going to divide your lens here, okay, so this is the center that the meaning is talking about, wherein it is thicker than the side of your lens. Okay, number two, so it makes an object or image look bigger. So another word is magnify. That's why if you are familiar with magnifying lens, so if you are using it, so you are making the object looks bigger because it brings light together, and another term is converge. Converge. So when do we use this convex lens? So it is very useful if you're using your projector and your camera. So this is your convex lens, by which this is the light source. So by which as your light passes through the center of your lens, so the light bends and it focuses to your focal point. So this is where your image is formed in your focal point. Also, the distance from the lens going to your focal point is your focal length. So in short, so this is what you mean by the word converge. Converge meaning the light is bring together at one point in your focal point. So how do we make this convex lens? So in your convex lens, so we are going to need two lenses by which each lenses are to be fused just like this one. Okay, and then after, so the manufacturer will be, so this they are going to remove this side. Okay, and what we'll have is your convex lens. So in this convex lens, so we are going to divide it into half, dividing the upper and the lower part of your lens. Also, your lens has its focal point. So this is your F, or you can call it as your F1, and then we can call it as your F2 or your 2F. Also, we are going to divide the lens sideways. So this will be what I'm talking about, your principal axis. Okay, so this is my principal axis. So in your principal axis, so that is where the light will bend. Please take note, the light will bend if it hits or it passes your principal axis. So this is your central point. This is the central point of your um, lens, or the center point of your lens na. Okay. Now, in making your diagram for your convex lens, so you don't have to draw your convex lens, but you're going to make a representation. So please take note of the lines here. So this is your principal axis, and then this is the symbol that will tell you that you are using your convex lens. Also, since light can be coming from this side or from this side, that's why we have two focal point and two F on this side. So in our example, so the object is in front of your F2. So again, this is your F2 or 2F. So using your ray diagram, so try to identify if what is the image. Is it big, small, the same? Or what is the image orientation, upright or inverted? Or is the image real or virtual? Okay, so the ray diagram for your lenses are different than your mirror. So for your lenses or for your convex lens, so we have to make a line that is parallel to this line. Okay, and then please make an arrow. So make a parallel line going to your principal axis, and from your principal axis you're going to make a line pointing to the focal point, to the F1 here. Okay, next, from the top of the object you're going to make a line that will pass the central point, like this one. And then you're going to make a line from this point pointing to the focal point. Okay, and when the light passes here, so the light will bend passing to or parallel to this line, just like this one. So in this example, we are using three ray diagram. So the first one, parallel, then to the focal point, passing to the central point, then focusing on the F1, then parallel and make a parallel line. So the area by which the three lines meet together, that is where the image is formed. So the question is, what is the image size? So the image size is smaller. Very good. And then how about the image orientation? So the image orientation is inverted, and the image now is therefore real. Now try to do this example. In your situation, the object is now at F2. So meaning it's on top of your secondary focal point. So for our example, you can use only two ray diagram, or if you want the three, then it's also okay. So please do this one. So image size, is it big, small, or the same? Is it upright or inverted, or is it real or virtual? Okay, so let's check your answer. So for our example, so we're going to use two lines only, or two ray diagrams. So the first one is from parallel going to the principal axis, and then from the principal axis going to your focal point. The second line will be from the top passing to the central point, like this. So the line or the two lines where they both met, that is where your image is formed. So what is the image size? So the image size is the same. What is the image orientation? So it is inverted. And then what is the image? The image is real. Okay, now what if you want to do this one, so you have to make sure na that the distance of your F1 to the principal axis is consistent. So meaning if I use this one 2 centimeter, then the distance also of your F2 to F1 is also 2 centimeter. So also on this side, so this one is 2 centimeter, and also this one is 2 centimeter. Okay, now so please be consistent with the distance so that you will have a consistent answer. So this will be your homework for your convex lens. So you are going to draw the image location that determine if the size of the image is big, small, the same. So the situation is between f1 and f2, and the second situation is on top of your f1. So please take note of the distance. So the distance should be 2 centimeter from each focal point. So you are going to write this in your science notebook. The next part is, let's have your diverging lens. So example of this is your biconcave lens. In your concave lens, so it does not make an image because it scatters or it spreads the light rays out. So you won't expect any image that will be formed on screen using your concave lens. So in your concave lens, so I have here 3 glasses or 3 plastic, and then we combine this one just like this animation. And then the manufacturer will be cutting this one so that you will have your concave lens. Just like this picture. Okay, so just like also with your convex lens, so we are going to divide this one. And then it also have its own f1 and your f2 focal point, and it also has its own principal axis. So it's basically almost the same. It's only the shape that is different. Okay, so please take note that in this example, so we are using this symbol. So the line is facing now away. So this is the symbol of your concave lens. So you can pause this video to think of the answers. Also, if you want to make this one, so make sure that you are observing the same distance. So this one is 2 centimeter, then the distance here is also 2 centimeters. Also, with this distance here, 2 cm and 2 cm. Okay, let's check your answer. So it's almost similar with your convex lens with a small changes. So first, you're going to make a parallel line going to your principal axis. And then the second one is we are going to make a line from your focal point going to your principal axis. And then from your principal axis pointing away, just like this one. Because remember that in your concave lens, the light spreads out, so meaning it moves away. Okay, so that's the reason the light ray is pointing away. And then the second one is the same with your convex. So from the top, and then it will pass the central point. So the line wherein they meet each other, that is where your image is formed. So what is the image size? So it's small. Image orientation is upright, and the image is virtual. Okay, next, try to do this one first before I reveal you the answer. Okay, let's check. So first, you're going to make a parallel line to your principal axis. Number 2, make a line starting from your focal point here and pointing away. Next is we're going to make a light ray diagram from the top passing to the central point. So the area wherein the two lines meet each other. So that is where your image is formed. So the image size is still small. The image is still upright, and then the image is still virtual. So this is your homework for your concave lens. So this time the object is placed at f1 and between f1 and principal axis. So write this one in your science notebook. Please observe the distance of 2 centimeters from each focal point. So you're going to draw the image location, the image size, image orientation, and if the image is real or virtual. So this is the end of the lesson for this video, M3. So I hope you understand about mirrors and lenses. So please do your homework in your science notebook, and once you're ready, so you can upload it in your Google Classroom. So once again, thank you very much for watching and have a good day. Goodbye.